We are in the final few minutes before we're about to lift off from Vandenberg Air Force Base with the Jason 3 spacecraft. I did mention earlier that there was a propulsion issue and the team was working. That was dealing with the Merlin vacuum engines. At this moment, though, we reviewed the data and both NASA and SpaceX concur that we are go for today's launch. Nothing to worry about, and that's going to affect our liftoff today. At this moment, you can barely see it on the screen, but the vehicle has fully pressed up. They did this about a minute or so ago, getting ready for the strongback retract, and you will actually start to see the white strongback on the right-hand side of the rocket in that image begin to pull back, and that's really the final few minutes before we're about to take off. Certainly the sweaty palms moment for me, and you can see it actually, the retraction is started, and there is motion at the forward end of the rocket. Meanwhile, the vehicle also transitioned to internal power about 2 minutes ago. That transition worked as planned, and we are ready to go. As you can see, that strongback in the forward end is moving away. It's going to tilt about 20 degrees or so and get ready for the Falcon 9 to lift off. Meanwhile, on the recovery side of things, we are dealing with 12 to 15 foot waves out of the drone ship. It's got a bit dicey out there. In this moment, though, we do think we are going to still make our attempt with the drone ship to land the Falcon 9, but it is certainly a lot more challenging to land on a moving sea platform than it is to land on the launch site, as you saw with the Orbicom mission earlier. And that weather, it does look like it's foggy there. It may make it a little bit difficult for us to see today's mission, but the ground winds are low at the launch site, as well as our upper altitude winds, so we have substantial margin for guidance through today's flight, both for structural and guidance navigation margins, whether it's going to hold out. So since everything looks like we are go for today's mission, let's check it out from Vandenberg Air Force Base, today's launch.
All right, so as you can see, the crowd is growing in anticipation here, and we're getting really excited. We're at just about the T-minus 3 minute mark. As you saw with the drone ship video that we showed you, that's really more than just a barge. It's actually a really sophisticated piece of equipment.
If you imagine that landing on a platform in the middle of the ocean is actually a much more difficult task than landing on a solid pad back on the ground, right? There's actually a lot of sea motion, like John was saying, the waves. So the spaceport drone ship, just read the instructions, actually needs to have a lot of systems to keep it in exactly the right spot so the rocket can come right down on top of the deck.
And it's about the size of a football field, which sounds pretty big, but whenever you are going just under Mach 6 and from 124 miles above Earth, that's actually a pretty tough target to hit.
Now remember, going into orbit is really more about going really, really fast sideways. So if you want to come back to a stationary drone ship, you have to cancel out all that velocity. It's a very difficult thing to do.
Just a note, we got confirmation that LOX load has been completed. So, landing the stage, there are 3 systems that let us do this. First one are the engine relights.
These are the same 9 Merlin engines that are about to blast it off the pad. A few of them relight several times to slow the first stage down as it comes back to the atmosphere and towards the drone ship.
Right, next one are the grid fins. These are what you might identify as looking like waffle fries on the side of the rocket, and they allow us to actually steer the rocket itself.
They pop up and use air resistance to guide the first stage right back to the drone ship in the ocean.
And lastly, the landing legs. So these are what pop out just before the first stage reaches the platform itself.
So we're actually getting pretty close to the launch. So we're going to take it easy right now and listen into the last few minutes before the Falcon 9 lifts off the pad.
Ground report vehicle gas supplies are isolated.
Vehicle gas supplies are isolated.
The vehicle's back in manual.
Good self-align.
VC, report flight software state changes. Wilco. Vehicles in auto idle. Vehicles in startup. Rock, confirm range is green.
Rock, range green.
T-minus 30 seconds. T-minus 20 seconds. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stage 1 ascent burn. Lift off of the Falcon 9. GC moved to section 57, post-launch pad operations to secure on net A.
GC to section 57, post-launch operations.
First stage propulsion nominal.
Vehicle is pitching downrange.
First stage PU is active.
Copy that. Ending pad aboard auto.
F9 power nominal.
And the Falcon
F9
9
telemetry
has
nominal.
cleared the launch pad at Vandenberg Air Force Base, delivering the Jason 3 spacecraft to a circular orbit about 1,300 kilometers away from Earth.
Vehicle altitude is 6.5 kilometers. Velocity is 280 meters per second. Downrange distance 1.1 kilometers.
And the vehicle is just transitioning into the supersonic regime. It's going faster than the speed of sound right now, and shortly we're going to reach max Q, or the maximum aerodynamic pressure. It's one of the highest stressed states on the rocket.
First stage propulsion remains nominal.
This burn will last for about another minute or so.
Falcon 9 power and
And then we'll
telemetry
have main
nominal.
engine cutoff, followed by our stage separation.
MVAC chill has started.
They've begun chilling in the Merlin vacuum engine, flowing the liquid oxygen through it, and that is actually a view from the thermal imager on the left side of the second stage.
Vehicle is supersonic. Vehicle has reached maximum aerodynamic
All
pressure.
right, so we had a great liftoff of Falcon 9 from Vandenberg Air Force Base.
So we actually have three really rapid events coming up right now. First is the stage separation, then is the relight, or the first burn of the second stage of the rocket, and then right after that, the fairing deploy. These are
Vehicle's on
really
a
right
nominal
rapid in
trajectory.
sequence, so we're just going to watch and see what happens here.
So while we're
Altitude
waiting for those to happen, let's talk a
55
little bit
kilometers.
about the orbital mechanics that we're going to be doing today. So for those of you that follow our launches on a regular basis, we typically launch our rockets from Cape Canaveral, and like we said before, we launch from Vandenberg Air Force Base. So that was confirmation that we had a successful main engine cutoff.
As you can hear, the crowd's very excited. This is a fantastic milestone.
Booster has been deployed. We had visual confirmation of stage separation.
As you can see on your screen right now, the MVAC engine has started up on the second stage, and it's on its way to our parking orbit before we get to
Yeah.
polar.
So the two views that you have on your camera there, the one that you see right now, or just had there, that's our infrared camera. That'll show shades of gray to display where the thermal dispersion is across the bell of the second stage.
And then the other view is a
Stage
visual
2B is
camera.
active.
Oh, we're actually looking at the fairing deploy right now. She's
all right,
coming
so we're
in
just
just a
waiting for
second.
fairing to deploy.
And we have successful fairing deployment. That's fantastic.
All right, that's great. These are all really important steps. This view that you see here, so that is second stage, pulling away from planet Earth. This is one of my personal favorites that we get to see.
You can see that MVAC engine bell glowing hot with the exhaust gases. It means we're
Yeah.
headed exactly where we need to be.
Okay, so back to the orbital dynamics for today. So the polar orbit that we're trying to achieve today is actually pretty important.
So normally when we launch geosynchronous or
Vehicle
low Earth
continues
orbit
on
missions to the
nominal
International
trajectory.
Space Station, we're usually taking an orbit that's pretty close to the equator around the Earth.
Let me give you an Earth.
Thank you. So typically we're going around the Earth in this direction. However, for a science mission like Jason 3, polar orbits are really important, and that's an orbit that goes the opposite direction of the Earth, so you pass over both the north and south poles.
Yeah.
This is really important for science missions.
Just like Jason 3. So like we said before, it's going to be measuring global sea levels, and it'll be doing this once every 10 days. So that snapshot that we get of planet Earth as it goes from North Pole to South Pole is really important and perfect for the job that Jason 3 has to do.
Now to get there, there's actually two separate burns you need to do. The first burn is what we're doing right now, and then there's actually a 45-minute coast period between the first burn and the second burn. That second burn will circularize the orbit to a final polar orbit and get it exactly where it needs to be for its science mission.
Yeah, so we're really excited. We had some great events today. Again, the view that you're seeing on your screen right now, That is the second stage as it is taking Jason 3 to polar orbit.
So in just a few minutes here, as soon as we get confirmation the first stage is coming back towards the drone ship, we'll be looking at the second stage one final time and then taking a 45-minute break before the second burn and satellite deployment.
Yeah, exactly. So just to recap everything that's happened, we had successful stage separation. We're waiting for the first stage booster to come back. We're going to be testing out landing on our autonomous spaceport drone ship, although like John said earlier, we're experiencing some pretty heavy waves out there. All right, so like we said before, we've had a really successful launch so far today. We're actually going to be sending it back up to John for a quick status update. Be sure to keep following along.
So far, we are on a nominal trajectory with that second stage performance. We are about 4 minutes away from the second engine cutoff, where we are going to park in our orbit and then get ready to deploy the Jason 3 spacecraft 45 minutes later after we do that circularization maneuver we talked about earlier. Meanwhile, the first stage has performed a successful flip, and it is on its way back to the drone ship. We'll know shortly how we're doing in the burns. The boost back burn has been conducted, and that was successful as well. You can see the image from the drone ship. We have the fire hoses there for some water suppression on entry as we are preparing ourselves for the touchdown in about 3 minutes or so. So at the moment, everything is proceeding nominally on today's mission. I'm going to keep my eye on the data here right now while you guys get the opportunity to keep watching this mission carry through.
So let's talk a little bit more about the systems that take the first stage back down towards the autonomous spaceport drone ship. Like John was saying, there's actually several different burns that are happening right now. There's 3 separate Merlin 9 burns that the first stage does.
Yeah, so the first one we've already done, like John said. We've actually flipped the booster around and we're bringing it back into the right place, lining it up with the drone ship.
That's called the boost back burn, naturally.
Yeah, we're waiting for confirmation of the second burn, and that's what actually will slow the first stage down so that it doesn't burn up as it re-enters the atmosphere.
We call this one the re-entry burn, again, for obvious reasons.
Yeah.
So when the booster's coming back at that point, it's coming back extremely fast, and if it's slammed in the atmosphere, it would not be good for the engines and systems. So we need to slow it down just a little bit so it's ready to enter the atmosphere without damaging it.
And then the third and final burn is what we'll be able to see. Okay. So the cheering that you see has been confirmation of the boost back burn has begun.
So it sounds like we're on our way back towards the drone ship, which is a fantastic milestone. Just got 2 more burns to go, and we'll be back in the drone ship.
I have to say, the energy here is palpable. Like, everybody's just so excited to see what happens. And just to reemphasize, this is a test that we're doing today, regardless of if we land successfully or not. We're going to get some really important data from the landing attempt today.
That's the most important. Even if there's a little bit of fire, it's not a big deal. This is exactly what we try to do. We learn from everything at SpaceX, whether it's a success or a failure. So
keep in mind that nobody is actually aboard the drone ship, and it's 200 miles away, so everybody is perfectly safe.
Now, just like the last launch was a night launch, so the landing berm was actually very visible, as you could see coming down for the last 100 feet above the pad. This one, it's still a little foggy in the drone ship, so I'm not sure if we're going to see it exactly perfectly, but you definitely will be able to see the rocket coming down towards it.
And like you see on the right side of your screen there, that is a live shot of just read the instructions as it's waiting for Falcon to return. We're at just under 30 seconds at this moment in time.
So the just read the instructions is actually the same drone ship that we've used before, just now it's on the west coast instead of the east coast.
Yeah, and then the thing that we're all waiting to see is the landing legs. So these are the 4 landing legs that will deploy from the side of the rocket so that the so that the rocket can set down and land safely without damaging the bells.
And these landing legs have a pretty big span, so it's actually really important that it comes exactly right down where we expect it to be, which means that the drone ship also needs to be exactly where the rocket thinks it's going to be.
Yeah.
So it has thrusters to make sure.
Okay.
Looks like we're just about to see the first stage coming towards the drone ship on your screen sometime soon.
It's so quiet here right now. Everybody's waiting in great anticipation.
You can see the extinguishing system on the drone ship right there. Hopefully in just a few seconds you'll be able to see the re-entry burn as the rocket approaches the drone ship.
Stage 1 landing legs have deployed.
Seco 1.
Landing legs have deployed. Looks like we should be seeing it soon.
Landing legs have deployed.
And stage 2
We've
is
also
in
had
boost
confirmation that we've had a successful cutoff of our second engine, so it's now entering the coast phase. Again, just waiting for Falcon 9 to set down here on our autonomous spaceport drone ship.
Looks like we might have a little bit of a problem with the video, but we are waiting to hear exactly what's happening.
Yeah. Just a reminder, this is 200 miles away. There's no Wi-Fi, unfortunately.
So it's
Copy.
unlike the pad shot we had the last landing. We may need to wait just a little bit to get confirmation of whether the landing was successful or not. But like I said, just to test, the primary mission is to get the Jason 3 satellite into its polar orbit, and that's what we're really all here for. It sounds like we just got confirmation that the parking orbit for the Jason 3 satellite in the second stage is good, which is fantastic. That means that we're on our way to our final polar orbit insertion.
Which, like we said before, that's going to be about 820 miles away from Earth. Also, the distance from New York City to Atlanta.
So like we said earlier, we actually have a 45-minute coast period between the second stage's first burn and second burn. Now, during this 45-minute coast period, we're not going to be here with you. We're going to be showing you a graphic that displays telemetry from the rocket so you can see exactly what the second stage is doing. And after the 45-minute window, we'll come back and guide you through the final burn and then also through the spacecraft separation.
Right, so these are still really important milestones. So we do hope you stay with us to watch as we have the final confirmation of payload deployment.
And we don't have any information right now about the drone ship and the status of the first stage, but hopefully we'll get some of that really soon. We lost satellite signal to the connection of the drone ship, but this is pretty normal during rough seas. It's a satellite link. It needs precise pointing, so it's not necessarily a bad thing. As soon as we have some information on that, we'll bring it to you, and hopefully it's a good land.
Unfortunately, just one of those days. We don't always have perfect weather here in Southern California. However, we're dealing with it as we can.
So now, once we go through we're about to sign off briefly for our 45-minute coast period, but we will be back. Don't go anywhere. As soon as that 45-minute coast is over, we'll be back right before the second burn, and then for the satellite separation.
Okay. Be sure to follow the animation, and we'll see you soon.